Hey everybody, this is quiz number 2, and it's going to serve as your practice exam number 2, and here we go. Now your numbers will be different than mine when you take it, but the type of question should still be the same. So I'm given the 2 points, -2, -4, and -8, +6, and they want to find the slope. And we are going to use our equation, our formula, and you can determine which ones. Be careful with this formula. Whenever there's a minus in the formula, you got to be careful that you're not missing a minus. That does happen. So 6 minus -4, you can see it right there, that minus. -8 minus -2. It's going to give me a 10 over -6, which reduces to a -5/3. Be sure to reduce your final answers. Question 2, they call it a T-table. In class, I call it an XY table. It all means the same thing, but we're going to graph the line 3x minus 6 using an XY table, or what they call a T-table. This means I'm going to replace x here to get an associated y value. So at x equals -1, so now we're here. That means that the point -1, -9 is on this line. At x equals 0, so there's my -6. So the point 0, -6 is there. And at x equals 1, so here are 3 points that are on the same line. And make sure we are in the shot. There we go. Make this extra big here. And I'm now going to plot the points. -1, -9 is way down here. 0, -6, 1, 2, 3, 4, 5, 6 is there. And then 1, -3, 1, 2, 3. And you can see they all make up a nice straight line there. Use my Starbucks card to make a nice straight line. There you have it. Problem 3. We are also going to graph a line. We have the equation -4x minus 5y equals 15. And they ask us to change it into slope-intercept form first and then graph it. Slope-intercept form, if you remember, is y equals mx plus b. So I need to isolate y by itself. So to do that, I'm going to add a 4x. then divide by the -5. Very nicely, we get y equals -4 over 5x minus 3. So now we have the slope and the y-intercept, and you can see the slope is a -4/5, and the y-intercept is -3. Now, if you recall, I said we're going to start at the y-intercept, which is the -3. And I told you even with a negative slope that we're going to rise, in this case 4, 1, 2, 3, 4. And now I'm going to run in the negative direction to here. Make sure you don't do negative, negative. Then you end up definitely with the wrong line there. And there you can see the negative slope, right? As x gets larger, y is getting smaller. Or more negative, I should say. Versus a positive slope that you can see there. All right, next up, number 4. All right, so we are, for number 4, trying to find the x and y intercepts. So to find the x-intercept, we set y equal to 0. So here's the x-intercept. On the y-intercept, we need to set x equal to 0. There is my y-intercept. All right, next up on number 5. What they want us to do is find the equation of the line with a slope of 2 over 5 that goes through the point 25, 0. So we're going to recall y equals mx plus b. And although this is not the y-intercept here or anything, it's actually the x-intercept, which doesn't help us. What we're looking for is m, which we have, and we need to dig out b. So I'm going to use this specific x and y and replace them in there and then solve for b. Be careful, it's always x comma y, but in this case, with this particular formula, you have to put the y in over here. Now here, I'm going to take 25, divide by 5, which is 5. 5 times 2 is 10. So now I have m and b, so I'm going to rewrite it with the new m and b in there. There's my equation of a line going through that point with a specific slope. Now, number 6 is similar in some ways. Number 6 specifically says that we want an equation of a line that's perpendicular to the line y equals negative 1/5 x plus 6 through the point to negative 9. Now, the slope of this line is a negative 1/5. Now, parallel lines have the same slope, but we're looking for the perpendicular slope. So the perpendicular slope to this one is going to be the opposite sign, so it's going to be a positive. And then I'm going to flip the fraction. We call that the reciprocal. So this has become a positive 5. 5 over 1 is just 5. So now I have a slope and a point. I'm going to do similar to what I did for number 5. I'm going to plug in x, y, and m. M is 5 now. Which tells me that my perpendicular line is 5x minus 19. I'm going to try to squeeze number 7 in here just to save some paper. 7 says that we are now looking for a parallel line, a line that's parallel to the line y equals negative 5x minus 3 through the point 3, negative 19. Well, we know the slope of this line is negative 5, and the parallel slope is the same, negative 5. So once again, I'm going to plug in x, y, and m. Solve for b. So now I have m and I have b. So my line, my parallel line, is negative 5x minus 4. All right. Next up is number 8. Flip the page over. Here we're going to have a system of equations. All right, so here's our system. Now, in this case, they've asked us to use the elimination method. And I'm going to choose to eliminate the x's You could choose to eliminate the y's, it really does not matter. And what I'm going to do is I'm going to multiply the top one by a -3. By doing that, I'm going to turn this lead coefficient into a -12. Then when I add it to this one, they will eliminate the x's. And notice that they're the same sign. They have to be opposite signs. So I'm going to multiply by a -3. And you'll notice all the signs changed because I multiplied by a negative. And by doing that, when I add these two together, you can see very nicely the x's are eliminated. And 12y minus 2y is 10y. 60 minus 40 is 20. And so we've gone from 2 equations with 2 unknowns down to 1 equation with 1 unknown, which is the goal, because we're supposed to be pretty good at these by now. So in this case, y is going to be 2. Now, that's only one of the 2 coordinates that I need. I now can take this y value and plug it into either here or here. I'll choose to do the top one. And you can see this is going to turn into a nice, easy linear equation. So my final answer is -3, 2 as an ordered pair. All right. A second. Copy it down if I need to. And number 9, I'm actually going to show you my screen here. So I'm going to switch screens so that you can see, because it's a word problem. So we have a man flies a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Because he was flying into a headwind, the trip takes 2 hours. On the way back, the wind is still blowing at the same speed. So the return trip takes only 1 hour and 30 minutes. So what is the plane's speed in still air, and how fast is the wind blowing? So if you'd like to take a screenshot of that, I'm going to go back to my, my paper. Here we go. All right, so for number 9, you can see we're looking for 2 different things, and I'm going to start off by letting x equal the speed of the plane without a wind. And I'm going to let y be the speed of the wind. And what's going to be happening is if the wind is going that way and the plane is flying that way, then the wind is actually going to push it, make it go faster. If the wind's going against the wind, then we have the speed of the plane, but the wind is slowing it down. And I'm going to set up a rate, time, distance table. Because we're going to use our old friend, rate times time is distance. We have 2 scenarios here. We have into the wind and with the wind. Now into the wind, means that the wind is slowing them down. So we have the speed of the plane without the wind, and then minus the speed of the wind. So it's slowing down the plane, making it take longer. When the plane is going with the wind, then we have the speed of the plane, and they get the help with it. Now, into the wind, it's going to take longer. In fact, it takes 2 hours, it says, according to the problem. On the way back, it says it takes 1 hour and 30 minutes. I want to show you how to convert that. So what you do is you take the 30 minutes and you divide it by 60, because there are 60 minutes in an hour. And this turns the 30 minutes into a portion of an hour. So if it's 1 hour and 30 minutes, that means it's going to take 1.5 hours, or 1.5 hours. Now the distance is the same for both. They're both going 180 miles. And that leaves me with rate times time is distance, rate times time is distance, rate times time is distance. And what I'm going to do is I'm going to divide the 2 and the 1.5 out. So 180 divided by 2 is 90. Often textbook problems will come out nice and pretty like this. Also, I have 180 divided by 1.5. You don't have to do this, by the way. This is completely optional. I think it makes the problem a little bit easier to do. And now you can see I can use elimination because the y's will eliminate when I add these two equations up. And you can see we're down to one equation with one unknown. This gives us that x, meaning the rate of the plane without a wind, can go 105 miles per hour. Now I'm going to take this equation here to figure out what y is. So 105 plus y equals 180. Means that y is now 75 miles per hour. Again, this is the speed of the wind. Y is the speed of the wind. I know word problems can be a little tricky. You may want to go back through this. Make sure you have it figured out. The only way to get good at word problems is to practice them a lot. I'm going to switch my screen again because we have another word problem here for number 10. Scott needs a total of $395 to buy a new bicycle. He has $35 saved. He earns $15 each week delivering newspapers. How many weeks will Scott have to deliver papers to have enough money to buy the bicycle? I'm just going to give it a minute so that you can look through it. You can take a screenshot, whatever you need to do. Hopefully you've gotten a screenshot by now. I'm going to go ahead and stop sharing. And we'll go back to the paper. So the trick with this one to figure out what you want to let x equal is, what does the question actually ask for? It wants to know the number of weeks. So I'm going to let x equal the number of weeks. And he starts out with $35 already. And the following week, you will have $35 plus $15. And the following week, you'll have $15 plus 2 times $15. Next week, 35 plus 3 times $15. And X number of weeks, it'll be $35 plus $15 times the number of weeks. So this expression represents, now, if it goes 0 weeks, Scott only has the $35. But every week, 1, 2, 3, 4, 5, that's how much more money he's earning. And his goal is to buy the bicycle, so he wants to total $395. There's the equation. That's always the hardest part of word problems, is getting to the equation, or equations, in the case of the previous one. So I'm going to go ahead and solve this. Minus 35, minus 35. That's going to be 360, I believe, 0, 6. So I'm going to go to my scratch paper here, go way over here. If you're allowed to use a calculator, obviously that's going to be a better option. And how long will it take Scott till he can get his bike? 24 weeks. All right, what are the last two questions? So I'm going to frame this. Number 11. And number 11, they're asking us to graph y is less than or equal to -5/3x plus 3. Now, I gave you 3 steps to follow when you got to these. First thing is put it in the slope-intercept form, which it already is. Next step is to graph it and decide if it needs to be dotted or solid. Now, because I have the equal symbol there, that's going to be a solid dot. 1, 2, 3, 1, 2, 3, 4, 5. So I'm going to start at y equals 3. I'm going to go up 5 and back 3. Again, you could go down 5 and to the right 3. You'll see we're on the same line. Both ways work. And again, this is going to be a solid line. And depending how you were taught, you could test a point not on the line. I'm not going to do that. I told my students that when it's in slope-intercept form, if it's less than, we shade down. If it's greater than, we shade up. So the shading of this, and you'll be expected to know that when it says graph the inequality, that you need to shade. It won't say shade the right region or anything like that. All right. We got one more to do. This is a system of inequalities. Last one. And you might notice right away that there's no equal symbols here. So both lines are going to be dotted. All right, my first graph, notice they're both already in slope-intercept form as well, which is nice. It's going to be my blue graph. I'm going to start here at 2. I'm going to go up 1 and over 4. There's my dotted blue line. Next up will be my dotted green line. So I'm at -2, and I'm going to go up 1 and over 1. And to be clear, this splits this up into 4 separate regions. We have up here, we have in between there, we have down below and to the right. And we have to figure out where we're going to shade. And this is my green graph. Now you'll notice with the blue, they want less than. So I'm either in this region or I'm over in this region. So I'm down below here. So I'm in one of these 2 regions here. This one says greater than. That's here or here. And the only place where that's both is right there. So where you shade is in between. Good luck on your test. I hope you nail it.